Welcome to Tuesday afternoon at DevDays. I stand in the unenviable position, I think, between everybody and drinks. Is that true? Drinks and nerd track? There's all kinds of fun coming up. But first, I have a different kind of fun, which is what is new in Smart 2. So these slides should show up in Whova at some point in the near future. They may already be there. Great. Let's dive in. So I've prepared a single slide which has a bunch of links to content that has landed in recent versions of the Smart specification. And the quick sort of historical tour is that we published version 2 of the Smart spec back in 2021. But healthcare timelines are long. Since then, we've published version 2.1 and 2.2, and we're just starting to see the first content from these specifications landing in regulatory requirements in 2026. That's in the US context. So we've got currently this implementation period where vendors have the option of implementing Smart 2, but they could still stick with Smart 1 for a little while longer. We're just starting to see these transitions. So I tried to focus yesterday's presentation on the stuff that you will really see in production across the board. And today I'm going to share with you a set of features that are newer to land, and may not be as consistently supported, but I think it's a really good set of capabilities, and we'll be seeing growing implementation over time. So a few topics to cover. I didn't spend much time yesterday talking about how clients authenticate when they're talking to a server with Smart on FHIR, but the short answer is there's a couple ways that it can be done, depending on the architecture of your app. So if you are building an app that runs entirely on an end user's device, so maybe this could be a browser-based app with HTML and JavaScript, like the demo that I showed yesterday, graphing glucose values. That's an example of what we call in Smart a public client. Public in the sense that all of the state of the application is visible to an end user. There's no place that you could keep a secret in that app and prevent it from leaking out into the world. And so necessarily, public clients do not depend on secrets for their security. Public clients are perfectly good first-class citizens in Smart, and their security comes from the fact that they are hosted at a domain that is controlled by the app developer. That domain is not controlled by anyone else. So it's registered with the EHR when the app first connects with that EHR system. And so I can say, when I register my app, I might associate it with joshuamandel.com. And anytime my app goes to get approved by a patient in the EHR, it's always going to redirect back to my domain, joshuamandel.com, to a specific page, which is called the redirect URL in OAuth. So a client like that doesn't actually need to authenticate. It doesn't get a secret that it's going to use or share with the EHR. It just receives an authorization code delivered to its URL. Other kinds of apps are capable of doing a little bit more in terms of maintaining secret state. So maybe you have an app that's running on a web server in a secure cloud environment or in your own facility. That's an app that has a server that nobody else can really get into. Your app can keep something like a password or something like a private key. So Smart describes these as confidential clients, using the terminology from OAuth. And confidential clients, since they're capable of authenticating, should authenticate. It only adds to the security posture of the app, prevents certain kinds of attacks. So in the very first version of Smart, we used only one method of client authentication, which is called a shared secret. At registration time, the EHR and the app both agree on what this shared secret's going to be. Works just like a password. The app keeps its copy, and every time it needs to authenticate to the EHR, it sends along that password, that shared secret, to indicate that it is authentically the app that it claims to be. And this is still the most common deployment scenario in OAuth 2. But it leaves some properties to be desired in terms of the overall security posture. One is that if you are registering an app with hundreds of different sites, you need to manage or juggle different secrets, one for each site, because you wouldn't want health system A to be able to impersonate your app when talking to health system B. So it becomes important to suddenly manage lots of these secrets. That can become unwieldy. So in Smart 2, we introduced support for asymmetric client authentication, which is to say that your application registers a public key with all of the EHRs that it needs to talk with. And anytime it needs to authenticate, it uses that public key to sign a cryptographic assertion in the form of a JSON web signature. So I won't go through the details of this confidential client asymmetric profile, but I will say this is what is being used for the preferred method today when an app is connecting to an EHR. You only need to register your set of public keys once, and you can connect broadly to a set of different systems without worrying about any secret information being shared. This is the profile that is already being used in bulk data in today's ONC certification program. So we reuse that mechanism for user-facing smart apps as well. There's not a ton to say about this asymmetric method beyond what I've described here, but if you're interested in the details of how those cryptographic assertions come together, there's a single page here, and then there's examples of what the workflow looks like at the bottom of this page, and it's linked to from this top of this slide. Now, more interesting things start to happen when we talk about token introspection. So this is a capability that allows some party who has an access token to ask the question, what is this access token good for? So typically, when a client requests an access token from a server, it learns from the server what the access token is good for at the time it receives the access token. So the server says, great, here's your access token, here's what scopes you can use it for, here's the patient that it's associated with. The app has everything it really needs to know. So what is token introspection about then? Well, this is about allowing additional servers in the mix who might need to look at an access token that's presented by an app. So the simplest way to describe this might be with a demo from a project we did in the Argonaut Standards Accelerator last year, where we used token introspection to allow two servers that run side by side and serve up different kinds of data to the app. So in this example, let's see. Let's try this way. I'm going to connect to an Epic sandbox. In this case, Epic is going to be providing the authorization services and generating an access token for my app. I can't remember if this is actually a sample patient that I set up, so we'll see in a moment, assuming I approve it. Okay, so this app got an access token, and it's able to make queries to the Epic clinical data server and fill out this box here. I just made some very simple queries to say, what's the birth date and name of the patient, how many problems and allergies and medications do they have in their record. So this is exactly what I showed you yesterday, standard Smart on FHIR workflow, talking to the EHR's FHIR server. What's happening down here is that I have stood up an additional FHIR server, an imaging data server, independent from the Epic sandbox, but capable of implementing the same access controls. So in particular, my app is able to talk to this imaging server and say, hey, here's an access token. What studies do you know about this patient? And in this demo, the imaging server manages its own set of DICOM files associated with the patient. But the imaging server has this important question it needs to answer before responding with a list of studies. It needs to know whether that access token is actually valid, and if so, what patient is it valid for? That's where token introspection comes into the mix. It allows you to stand up an additional resource server that can host more data and implement the same access control policies as the EHR, specifically filtering the data down to the right patient, the right time frame, and the right resource types or scopes that have been shared. So in this example, my imaging server actually just talks to Epic's token introspection endpoint. It says, hey, I just saw this access token. Is it currently valid? What patient is it valid for? And what scopes is it good for? And if it sees satisfactory answers there, then it will return a set of FHIR imaging study data and DICOM data. And this gives you an example of how you can start to build a cluster of servers that can manage separate concerns separately. They can be built by different teams on behalf of different organizations with different data modalities. And token introspection you can think of as the glue that holds this all together. The really important thing from the patient perspective, as the end user authorizing this app, is that I only needed to sign into a portal account once. I only needed to make a decision about what to share one time. And having done so, I was able to share data with the app that covered both the clinical stuff and the imaging stuff. So let me pause before I continue working down the new features list and just see if there's questions about what I've shared so far, because these are a grab bag of independent topics in Smart 2. Okay, I'm going to assume that means so far so good. Raise your hand if you've understood what I've said so far. Okay, great, awesome. Let's talk about endpoints and authorization. So building on this concept that you could have multiple different servers in the mix, we've added a couple of capabilities into the smart discovery features that allow apps to learn things like what other servers might I need to talk to if I need to get additional data. So let me show you, first off, a property that we added to the smart discovery document. I didn't go into detail on discovery in yesterday's presentation, but every Smart on FHIR server will host a file that looks something like this at a specific URL called .wellknown/smart configuration. So if you're a Smart on FHIR server, you host a smart discovery document that gives an app the information it needs in order to connect. It tells the app things like what scopes are supported by this server, what capabilities in Smart does this server support. And this is a new piece that we added in Smart 2, which is what are some associated endpoints. So a FHIR server, if the FHIR server supports Smart on FHIR, you can always get this particular discovery document relative to its base URL. But this is how you can learn about potentially other servers, including other FHIR servers, like an imaging server, that might be able to accept the same access tokens and work as part of a federated system. So this is just a piece of metadata. It's the metadata that we use, if the server can support it, to enable that imaging workflow. But not all servers are going to support this piece of discovery. So we say, if you can get it in band through this mechanism, great, you use that. If you can't, you can always just somehow hard code a set of data that you learned about out of band. This is the fallback position. But it's really useful if you can get it directly as part of this discovery document. And then together with this, we had a use case from the folks at Epic where they said, well, we actually have like 2 or 3 FHIR servers for every customer. There's a FHIR DSTU2 server, and maybe STU3, and a FHIR R4 server. And the interesting thing about it is that they all support slightly different sets of resources, and your patient ID might be different in those 3 servers, even for the same individual patient. So the question there was, how can we tell this story to an app? I just launched the app. If you're talking to the main FHIR server, let's say the FHIR R4 server, we know how to communicate the patient ID. But how do you tell the app, oh, by the way, you might also want to talk to this FHIR DSTU2 server for some other stuff. And if you do, you'll need to swap in this other patient ID. How can you communicate that? So this is a capability that we've added, which is labeled as experimental, which is why it says experimental and EXP and is in a colored box here. We try to make this really loud when we've introduced these experimental features in the spec. But it allows the server to return a set of authorization details that augment the access token response. So in particular, we can just look at an example here. All of these are the normal properties that an app would get when it connects to a FHIR server. So what patient are we talking about? What scopes? And the FHIR server is implicit, because by the time you've completed this authorization flow, you know which FHIR server you were trying to authorize against. But meanwhile, you might learn some details about other servers you can connect to right in line in this process. So in this case, the authorization details will tell us there's a Smart on FHIR server that lives at this URL that supports FHIR version 4, and another Smart on FHIR server that lives at this URL that supports FHIR version 1, which is DSTU2. And by the way, if you're talking to this one, you've got a slightly different set of scopes to work with and a different patient ID that you need to know about. So you might think this is an edge case or kind of an advanced pattern, but the truth is I think these kinds of architectures are going to be more and more common as systems grow. It can be really painful to just rip out support for older APIs when you enable new ones, and it can be hard to keep the feature set totally up to parity when you introduce a new server. So this mechanism gives us some way to do a better job of asynchronous cutover, where you have 2 services available at the same time, maybe forever, or maybe just during some transition period. So I'm going to pause again and see if folks have questions or comments about this capability to surface information about associated endpoints and the authorization details. Yeah, I see maybe 2 hands up. If we've got mics, that's great. Otherwise, if you shout, I'll repeat the question.
So my question is that if you have a FHIR server in which our authentication is standard, like our authorization is the different scheme
So the question is there a mechanism to support a custom authorization scheme? I mean, SMART sort of exists to define a standard profile around authorization schemes. We call out a couple of them. There's one for user-facing apps and one for backend services. You could certainly support those in SMART and then also support other things in your server. And so typically, those other schemes will have their own discovery mechanisms. An example of one like this in the US would be the UDAP authorization scheme. And so if a server supports SMART and UDAP, it would have a SMART discovery document that lives at .well-known/SMART configuration. And it would also have a UDAP discovery document that lives at well-known/udap.json. So that's typically the pattern. You can support any things you want and compose them with SMART, but we don't have much to say about it in the SMART spec itself. Yeah, another question, please.
This is in relation to the recent work done for SMART on OpenAir, and there might be more APIs that want to work with SMART, which are not necessarily FHIR.
Yes.
So in that case, and again, like DICOM Web is another example, but in that case, would that go in the associated endpoints first? And if in case they also have a different EHR ID or if a different patient ID in the system, does that also show up in the access token response?
So both of these things are possible. In other words, let's say your EHR has a FHIR server and an OpenAir server. You could describe the OpenAir server here. This is for static discovery. And that would be basically saying, hey, this FHIR server is always associated with this OpenAir server or this DICOM server. So that's how you can surface information statically. The other place that I showed you inside of the access token response is used to surface information dynamically. So now that you've been given access, by the way, you can take this token and use it at this specific other spot with these specific other tokens. So those are both useful. They're slightly distinct. It certainly makes sense to use them together if you're controlling the authorization server and you can land data in both spots.
So in the associated endpoints, we should also be seeing other versions of the FHIR endpoint, right?
This could point to another FHIR server for sure, yeah.
Thank you.
Absolutely. Other questions on this? Yeah, one in the back on the left. Hold on, you got a mic coming.
For the associated endpoints, does the same token work, or does the user need to re-authenticate?
So the expectation here is that the same access token can be used at associated endpoints. What do we say here? Array of objects for endpoints that share the same authorization mechanism as this FHIR endpoint. So if you have a different scenario where you're really just trying to say, look, I'm not giving you access, but here's another place that you could go and try to get access, we would want a different property name to surface that information. Other questions or comments? Yeah, I see Jason. We're really making you run around. Thank you for that with the mic.
Where? Oh. Yeah, I was just going to say we give them a workout here. Okay, so the associated endpoints are for things that you should be able to get access with the same token.
Yep.
But when you go to the app launch, where there's multiple different servers, in your words, with potentially different FHIR versions, are they expected to have the same token?
Yep, these are also servers that, this is part of the access token response. So I'm telling you, here's your access token, and here's all the places you can use it. So we're really focused on this kind of tight integration where, I mean, this is kind of the point of this spec, is these servers are going to work well together in this fashion. There may be looser integration scenarios that we could also model, but they haven't been a priority up to now.
Okay, so basically when you broadcast that you have the associated endpoints, then the client does not have to request anything additionally to be able to access those endpoints, as long as they're
as long as the
broadcasted?
scopes have been worked out in a way that the parties are comfortable with. So for example, when you're approving an app in the EHR FHIR authorization flow, maybe you're approving it for a scope like imaging reports, and that's going to make the imaging server comfortable exposing those data. There are some real challenges here that we shouldn't paper over. For a patient-facing authorization flow, it's very important to be able to explain to that patient in line, hey, here's what you'll be sharing if you agree. And so that might need to cover data from more than one system. But typically, the patient doesn't care where the data are coming from. They care what the data are. So like, you wouldn't necessarily need to explain to the patient, oh, you'll also be sharing data from this DICOM server. You want to explain to the patient, you'll also be sharing access to your images.
All right, thanks. I might have some more offline questions later.
For sure. And as I said, this is sort of experimental stuff, so feedback is good on this. Another question, please.
Yeah, I can see the experiment feature of the patient ID. It's very good. Have you ever considered another edge cases like the system can resolve different user ID? For example, the practitioner ID right from this system may be different from other system.
Yeah, so I think the short answer is that we haven't. We communicate who the user is as part of the OpenID Connect flow. And the important thing is that the client application can get a resource representing that user. We haven't heard a use case for wanting to request that resource from more than one server because there should only be one source of truth about who the user is who's running the app. Other questions? Yeah, I like this zigzag pattern. We're maximizing steps.
Hi, thanks. I was wondering if there's a use case to have a single endpoint that could then go to multiple FHIR servers using this stuff.
Yeah, so you could think about building a lot of interesting things in the, sort of as a pattern on top of this. You could also think about building essentially an API gateway that manages or proxies data coming from lots of places. And if you sort of follow that train of logic, you don't really even need to tell the app about multiple servers anymore. You just have one server that looks as though it had all the data. So there's a few different patterns architecturally that you can build on top of this. And our goal with the spec has been to enable those in a reasonably flexible way while still giving the app some fixed set of steps that it can follow to find everything that it's allowed to see. Yeah?
So in this example here, with the new scopes, with the same token, how does that work?
Can you say that again? I think I missed the question.
So here you have two servers using the same token. The second one has different scopes from the first one.
So good eye. Specifically what's happening here is that smart scopes are tied to FHIR resource names, and FHIR resource names sometimes change across FHIR versions. So what used to be called medication order in FHIR DSTU2 is equivalently now called medication request in FHIR R4. The way that you would explain it to a patient at authorization time is the same. You would say, do you want to share your medication information with this app? So patient says yes. But to convey those in smart scopes, you have a slightly different resource name in the different versions. So that's what explains the repetition of this field and the difference.
Would they be prompted to approve those scopes?
No, so the patient flow here is they are presented with a set of data to share. Each of them has those checkboxes like I showed you in that Epic example. And they share what they want to share. The patient doesn't know or care whether some resources are coming from a FHIR R2 server and some from a FHIR R4 server. We're in trouble if patients have to understand that.
And what about the case where the search is supplied as a FHIR search string? What happens when you go down to the DSTU2 version?
So I think we quickly get beyond what we know how to specify here. The key point to highlight is scopes are a negotiation. So an app can request certain scopes, and then based on what a patient has to say, and based on organizational policy, a different set of scopes can be granted. It can be more than you asked for, it can be less than you asked for, it can be different than you asked for, and that sort of gives the EHR enough flexibility to do what it thinks it needs to do. Okay, cool. I want to talk about another capability that we introduced back in Smart 2.1, which uses this associated endpoint trick. This is a feature called App State. And the goal with this was to allow applications that are mostly just like a static web app to have somewhere that they can persist things like user preferences. So maybe you've got an app, the users are going to be healthcare providers, and they can drag different tiles in the app into just the configuration that they like. And they don't want to have to do that every time they run this app on a new workstation. They want to be able to store their preferences about that configuration. If the app is otherwise just a static web app, it really doesn't have anywhere to put that config data. So this Smart App State API is another experimental feature, which we added so that EHRs can support the storage of small bits of information associated with the user or associated with the patient. And again, I won't go through all the details here, but the sort of key aspect to think about is, first of all, at discovery time, if a server supports this functionality, it advertises the endpoint where it's available and the fact that that's the Smart App State capability. Now, that endpoint could just be the regular Smart on FHIR endpoint where all the other resources come from. That's perfectly fine. But maybe the EHR says, well, I'm going to have a dedicated data store just for managing this app state, and I'm going to keep it as a separate endpoint so that I can isolate that team and the functionality. So we offer that ability to host it somewhere else if you want to, and the app discovers it this way. And then once the app is talking to one of these endpoints, it has a very limited API that it can use to communicate with it. The core of it is you post to the FHIR basic resource. And basic is essentially the FHIR resource that is a placeholder for other stuff you want to say that's not modeled somewhere else in FHIR. It's a resource that is almost an empty shell, but it can be associated with a subject and a code, so we use those properties, and you can add extensions as needed. So the way that we model app state here is we say, great, the app posts some state that's either going to be associated with a patient or a practitioner. That's the subject. The app assigns some code, which is like, what does this state mean? So in this case, it might be the user's display preferences. And then the app supplies an extension where the app can call the extension whatever it wants, and it can put whatever details it needs to into a string. So it's a very basic box. We limit the size of how big these extensions can get. I actually forget what the cutoff that we made here, but it was maybe a couple of hundred kilobytes. We say the total size of the post shall not exceed 256 kilobytes unless the EHR specifically documents that they have a higher limit. So this is an API that's designed to be very easy to implement on top of cloud storage primitives and can be useful for apps that need to persist information when they only really need a little bit. Preferences is one simple example, but the other example, which I think is pretty cool, comes out of work that Apple has done for surfacing data inside of an EHR based on information that lives on a patient's mobile phone. And the workflow they have there essentially involves saving a decryption key as a piece of app state, and then hosting only an encrypted copy of the data, so that when a clinician goes to view those data in the EHR, the encrypted data can be fetched and then decrypted using a key from app state. I don't have a diagram for that story, but it's spelled out in a bit more detail in the web page as an example of one of the motivating use cases. And the other very simple demo that we have that we built out along with the app state spec is this very impressive app that will store your favorite color in the EHR, and then at any point you can reset it. And it gets remembered across reloads, so it's really quite magical. And you could sign in from a different device as the same practitioner in our sandbox, and you would also see deep sky blue, or at least that is the theory. So very simple example of an app that does this using about 50 lines of JavaScript. I link to it from the slides in case anybody wants to check it out. But it's a pretty straightforward pattern where you post a basic resource, and then later you search for that basic resource, supplying the subject and the code associated with your use case. Okay, last topic for the grab bag is user access brands. And this is one that is, you can think about this as part of what's in the ONC requirements to support by the end of the year. I'll put an asterisk there, and you can come grab me if you want to get into the nitty-gritty details. But by the end of this year, the EHRs need to support some FHIR-based mechanism for discovering the endpoints of all of the customer sites where the FHIR APIs are available. So you might have an EHR with hundreds of customers around the US, and there's got to be some way, some place, where that EHR vendor is going to host a FHIR bundle that has the FHIR endpoint details for each of those customers, as well as the details about like what organization each endpoint corresponds to, the name of the organization, and so on. Now, through talking with app developers, we quickly learned that if you want to build a good user experience, you need more than just the name and the address of a FHIR endpoint. Otherwise, you wind up asking the patient what health system they want to connect to, and the patient is like, I want to connect to Mercy Health. And there's like dozens of organizations with that same name, totally unaffiliated with each other, all using different EHRs. So you can't build a good user experience around that level of data alone. And this is why we developed the User Access Brands and Endpoints project. This was one that we ran in the Argonaut Standards Accelerator, and we came up with a set of FHIR profiles for the endpoint resource and the organization resource that essentially boil down to this. Beyond just the name of an organization, how do we communicate the website where that organization hosts its main content, the logo that that organization uses, any aliases or alternate names that the organization is known by, any identifiers, like that could be something like an NPI, or it could be something like a web domain that's associated with the organization. Any specific locations where that organization does business, could be states or cities or clinic sites. What category of patient data does this organization make available? Is it sort of pharmacy data? Is it clinical data? Is it imaging data, laboratory data, and so on? And what patient portals does the organization offer? So what are the places where patients could go to actually connect an app to their own record? And those portals, in turn, are each associated with their own name and logo and description. So essentially, this is patient or user access brands. A couple of FHIR profiles that let us document these details about organizations and endpoints. And we have a set of examples that sort of talk through how these things can be used. Very quickly, when you start thinking about healthcare organizations, you realize that there are complex and dynamic relationships between these organizations. Organizations merge, they split, they rebrand, they switch EHRs, they add an EHR, and so on. And our goal here was to be able to cover like the actual inherent complexity in this domain without making things so baroque that app developers are unlikely to be able to process the information. So there's a few canonical examples that we write up in the guide, which I'll spend a couple minutes on so that you can get a flavor for this. So maybe the simplest one that we call out is you've got a national lab that has many locations around the country. And so in an app, you kind of want this to show up as a patient-facing card like this, where it says, example labs, the nearest location is 1 mile from where you are right now, and you can connect to their API, or you can go and see their portal on the web. And to convey this kind of information, we have a FHIR bundle, which is what we call a branding bundle, that has all the details that are needed to render a card like that. So in this example, we use these FHIR extensions to convey this information. So there's one that describes the organization itself, where we can convey the logo that the organization uses. And then there's one for the portal details, which is what's the portal called, what's the URL of the portal can have its own logo, and so forth. We say this is an organization that's going to be conveying lab data, so that's a category, and then can have a name and aliases, and it can have a whole list of addresses. So we can see the states and cities in which it does business. And this could be very long, so I included a little ellipsis here to say, like, maybe there's 1,000 locations in this list. Maybe this resource is going to get pretty big. But this is a way that you can communicate the details about a national lab to allow an app to present it in the right place downstream. Perfect. Another example would be a regional health system. This is actually the case of my own healthcare provider in Madison, Wisconsin. There is a regional system that operates in about 4 states around Wisconsin. And my healthcare provider isn't really branded as part of this regional organization, but they do use that organization's Epic EHR, and that's where they keep their records, and that's how they give me access to my Epic MyChart account to make my data available to me. So how do you tell this story? You say, okay, there's this organization called Example Health, which might be a broad organization that operates in 4 different states. But also there's a sub-organization called Example Health Physicians of Madison, which might have the same patient portal. And then there's an example of a community hospital, which is also a sub-organization of Example Health. So as a patient, I might not be familiar with Example Health as a brand. Maybe I'm a patient at Physicians of Madison or at this community hospital. And so they can choose to model their information in a way that it will show up as 3 different cards in a patient UX. They can represent it as 3 different organizations with this parent-child relationship. And again, there's a brand bundle that describes how you can tie that parent-child relationship together. I won't go through it in full detail, but I'll just show you that the child organizations indicate that they are part of this parent organization, Example Health. So you can start to tell these hierarchical stories about how organizations are related to each other. Here's another example where you might have, this is again drawn from real life, from my experience at Boston Children's Hospital. You might have an organization like the Dana-Farber Cancer Center, where they see adult patients and they see pediatric patients. And actually, for the pediatric patients, they use the EHR system from Boston Children's Hospital down the street, which up until very recently is a Cerner system. And for adult patients, they use the system from the Mass General Brigham in the other direction. They still might want to show up as one card in a patient-facing app to say, you know, this is the Dana-Farber Cancer Center. But they do want to be able to convey that, hey, if you're a pediatric patient, you need to connect to this FHIR endpoint or to this portal. And if you're an adult patient, you need to connect to this other FHIR endpoint or this other portal. So you start having to be able to explain, okay, for each of your patient access options, which patients are they appropriate for? And so this example JSON bundle starts to tell that story, and we convey this through properties like the portal description. So it might say, Patient Gateway is an online tool to help adult patients, and the other one might say, Pediatric Portal is the entry point for pediatric patients. And apps can surface this for users to help them select the right endpoints to connect to, which are the ones where they're going to have accounts. And then the last example here is, you might have 2 organizations that have merged, but they're still maintaining separate branding for now. I won't go through the details of it, but this is, again, something that we try to account for in the specification. If you're interested in exploring this or playing with this anymore, there is a couple of tools that I've linked to from the slides. One is a brand editor, so you can just sort of type in org names and details, and you get a brand bundle out here along the side, so you can see how your metadata is surfaced in that bundle. And the other one is a brand browser, which can take in those bundles and display them in a way similar to what a real patient-facing app might do. So I've loaded this with a couple of sets of sample data, including the ones from the spec that I was just showing you, but also one from Fasten Health, which has pulled together a database with thousands of organizations that they've massaged into something pretty close to the brand bundle format. And then I took the next step and represented those as brand bundles. So you can get the sense that even pretty quickly, even if you're grabbing these data in real time, you can render these to the screen and do a reasonable job of searching through them. I wonder what's in Minneapolis here. So you can pretty quickly search through these. Overall, I would say apps generally don't want to do this in real time. They would probably update all of their brand bundle information in some kind of background job, save it in a database where it's going to be super fast, and then deploy that to the end users. But it's actually not unworkable to do this whole thing in real time. So that's all the content, the grab bag of what's new in Smart 2, 2.1, and 2.2. If there are any final questions or comments on any of what I've shared, I will be happy to open up for those.
On the topic of brands, like, is there a way to notify the app developer when something happens? Because most likely, like you're saying, you're doing the background job and you don't expect the logos or the endpoints or whatever to change very often. Is there a way to notify?
I didn't get the whole question, I'm sorry.
Okay. Is there a way for the brands topic to notify the apps or anything when the logo changes?
Is there a way for the brands to leave out, not define?
Notifications. So if a logo changes, is the app expected to constantly update?
Oh, I see.
Okay.
Yeah, so, I mean, this is a little bit beyond what we specify in our implementation guide, but the expectation is that apps will stay up to date with the brand bundles that are published by EHR vendors. Each of them, might set a different policy for how often to stay up to date or what that polling frequency might be, but we do have functionality in the brand bundle spec to allow apps to easily only request things if they've changed, and to be able to tag entries with how recently they've changed. So that should make that job of staying up to date a little bit easier.
Okay, thank you.
Sure thing. Any other questions or comments? One all the way on the side.
Is there any capacity for the same brand that might need to be represented in different languages with different logos? Is there any way to express that?
So the question is about representing a brand in multiple languages or with different logos, yes? Yeah. There's a generic capability in FHIR to tag a resource with a language, a base language, for which the resource has been authored. So you could build a brand bundle where you tagged these individual organizations with one language or another, and then just represented the same organization multiple times for each target language. It's not a topic that came up in any of our discussions, but it's a great question. There's a couple other approaches you could take. FHIR also has extensions for translating individual strings. So you could have just one organization and then translate just the individual fields into specific languages. The only real use case that came up around internationalization in the course of the project had to do with locations. And it was a very late-breaking change that we recommended including the country in every address where we represent an organization. And that probably speaks to an overrepresentation of folks from the US market participating in that design process. But it is a really important question.
Here's another one.
Yeah, please.
Yeah, I wanted to go back to the middle of your talk because it takes me about that long to frame my question. But I was very excited about the idea of using an authorization token to access two different servers, and then you talked about a similar potential pattern of using authorization token to access a single server, which might proxy requests to two different servers. We've been kind of going back and forth on that same pattern choice for the last year or so, and I realize your point was mostly that that the Smart Launch 2 supports either one. But I'm curious if you have any comments about the difference between those patterns. Our use case is not, are supporting R4 and supporting some older version of FHIR, but it has more to do with, distinct and semi-overlapping sources of data.
Yeah, so it's hard to look at this generically. I guess what I would say is if you are in a position to be maintaining the server that is the one an app is interacting with, and you're willing to proxy, that definitely keeps things cleaner. It gives you more observability into how the access tokens are being used, and it gives you more control to change how the connections are made without breaking applications, because to them it just looks like one server. So I would say if that is a pattern that you can enable, it's worth doing. But there are complexities here, particularly around things like search, where you might have many, many pages of results, and now you suddenly need a strategy for saying, well, how do I collate the different pages that are coming from different sources and make it look reasonable or make that transparent to the app? So there are certainly complexities there too. All right, well, thanks everyone, and looking forward to what's coming up. The nerd talks, yeah? Drinks and nerd talks, wonderful.
Thank you very much, Josh. Thanks very much.